One single factory in the red deserts of Western Australia is about to create enough food to feed 90 million people every single year. This is the $6.4 billion Perdaman Urea project, a massive build that stands as the largest industrial construction project in the history of the country. To build it, workers are using 111,120 cubic meters of concrete and over 46,000 tons of steel structures. The plant uses 3,200 kilometers of electrical and data cables to control the world's largest single-train ammonia reactor. But how do you build a city-size chemical factory in a place so hot and remote that every single piece of steel has to travel 13,000 kilometers across the ocean just to reach the site? The history of this massive project started with a man named Vikas Rambal, who arrived in Australia in the year 2000 with only a return ticket and a big idea. He was a chemical engineer born in Delhi, India, who had spent his early career working for large oil companies like Bharat Petroleum. One day, while he was sitting on a park bench in the city of Perth, a stranger sat down next to him and asked what he did for a living. Vikas explained that he knew how to manufacture ammonia and urea, which are the main ingredients used to make fertiliser for farms. That stranger happened to work for a government department and introduced Vikas to the people who could help him turn his idea into a reality. This chance meeting on a park bench was the spark that led to the creation of the Perdaman Group. Before this project, Vikas was the driving force behind another plant called Bharat Fertilisers, but he later sold his share in that business to start his own company called Perdaman. He realised that the world was facing a huge problem with food security and that Australia was buying almost all of its fertiliser from other countries. By using the natural gas found in Western Australia, he knew he could build a plant that would make Australia self-sufficient. In the year 2017, both the state and federal governments recognised the project as a project of state significance, which helped it move forward faster. This plant is not just a business for Vikas. He describes it as a dream built on hard work and the lessons his father taught him about math and science back in India. But how exactly do you take natural gas from under the ocean and turn it into the tiny white pellets that help corn and wheat grow? The main job of the Perdaman plant is to take natural gas and turn it into urea pellets. This is done in a giant, continuous process called a single train system, which means the whole factory acts like one long assembly line that never stops. The factory is divided into two main parts, the ammonia plant and the urea plant. The ammonia section uses a very advanced technology called Syncore from a Danish company called Topso. This is the first time this specific technology has been used on such a large scale for an ammonia plant. In a traditional plant, you need two big steps to break down the natural gas, but the Syncore system does most of the work in one single reactor. Inside this reactor, natural gas is mixed with steam and oxygen at very high temperatures to create a mixture called syngas. One of the biggest engineering wins for this plant is its steam-to-carbon ratio of only 0.6. In older plants, this number is usually 3 times higher. By keeping this number low, the engineers can use smaller pipes and smaller machines, which saves a lot of money and energy. The reactor is lined with many layers of special bricks that keep the outside metal shell from melting, even though the inside is incredibly hot. After the gas is broken down, it goes through a shift section, where it is turned into pure hydrogen and nitrogen. These two gases are then squeezed together at high pressure to create ammonia. This ammonia is the building block for the final product. If you think the ammonia part sounds complicated, the next step where they turn that gas into a solid pellet is where the real magic happens. Once the ammonia is ready, it moves to the urea section, which uses technology from an Italian company called Saipem, known as the Snamproghetti process. This is a double win because it uses up a gas that would otherwise be bad for the environment. Inside a massive reactor, these two ingredients are squeezed at a pressure of about 150 times the weight of the air around us. This pressure forces the gases to turn into a liquid called ammonium carbamate, which then turns into liquid urea. To make sure the plant lasts for 40 years, the engineers use a very expensive and tough type of steel called Saphorex. Standard steel would be eaten away by the chemicals in just a few months, but Saphorex has a special mix of metals that makes it almost impossible to rust. After the liquid urea is made, it contains too much water, so it is sent into a vacuum where the water is sucked out until the urea is 99.8% pure. The final step is called granulation. The hot liquid urea is sprayed into a big tower where it meets a blast of cool air. As the liquid falls, it turns into hard, round pellets, about 2 to 4 millimeters wide. To make these pellets even stronger so they don't break when they are moved, the plant adds a special coating called UF80. A company in Western Australia called Hexion was given a $90 million contract to provide 16,000 tons of this coating every year. But before any of these pellets can be made, the entire factory had to be built in pieces on the other side of the planet. Because the plant is located in a remote part of Australia where it is hard to find enough workers and materials, the engineers decided to use a modular construction method. This means they built the factory in 110 giant pieces called modules in a special yard in Chennai, India. These modules are like giant building blocks. The largest one is 16 meters wide, 42 meters long, and 33 meters high. The heaviest module weighs 2,700 tons. Moving these giant blocks from India to Australia is a massive job. They use a special ship called the AAL Dampier, which has cranes on its deck that can lift 700 tons at once. The ship has to travel 13,000 kilometers across the ocean, and the crew has to make sure the modules stay perfectly still even in big waves. When the ship arrives at the port of Dampier, the modules are carefully moved onto trailers with hundreds of wheels that are controlled by computers. So far, 31 modules have already arrived and been bolted into place. The precision is so high that these 1,000-ton blocks have to line up within a few millimeters to make sure the pipes can all be connected. While the modules are being shipped, the team on the ground in Australia has been busy moving enough dirt to fill a stadium. Before any modules could be placed, the construction team had to prepare the ground on the Burrup Peninsula. A company called Deckmill was hired to do the bulk earthworks, which involved moving 901,415 cubic meters of material. The ground there is made of very hard rock and salt flats. To flatten the area, the team had to use 4 big drilling rigs to blast the rock with 109 separate explosions. They then crushed 2,200,000 tons of that rock to use as a base for the factory. The site is split into 2 main areas connected by a road called a causeway. This causeway had to be built across soft salt flats, so the engineers used large steel pipes called culverts to let the water flow under the road without washing it away. The plant also needs its own power and water. It will have its own power station that produces 101 megawatts of electricity from gas turbines, plus another 5 megawatts from a large solar farm called Project Helios. To get enough water, the plant uses a special system that takes seawater from the ocean and removes the salt so it can be used in the chemical reactors. Every part of the site is designed to be as efficient as possible, but after the urea pellets are made, how do they get them onto ships without making a mess? Once the urea pellets are finished and coated, they are stored in a massive shed that can hold 75,000 tons of product. To get the urea from the factory to the ships at the port, the engineers are building a 3.5 kilometer long conveyor belt. This belt is not like the one you see at a grocery store. It is completely enclosed inside a tube so that no dust can blow away into the environment. It travels along a special path called the Burrup East-West Service Corridor until it reaches the port of Dampier. At the port, the conveyor connects to a huge machine that can load urea directly into the hulls of ships. They expect between 50 and 100 ships to visit the plant every year. This system is designed to move the urea as fast as possible while keeping the area clean. The entire plant is a marvel of modern engineering, but building it on land that has been sacred for 50,000 years has brought some very difficult challenges. The Burrup Peninsula is home to one of the world's largest collections of ancient rock art, with over 1 million carvings called petroglyphs. These carvings were made by indigenous people and show animals that are now extinct. To build the plant, the company had to move 3 specific rock art panels to a new location. This caused a lot of controversy and pain for the traditional owners of the land. The government and the company have promised that this will be the last large industrial project built in this specific area to protect the rest of the art. There is also a worry that the tiny amount of gas that comes out of the factory's chimneys could make the rocks more acidic and cause the art to fade away. To stop this, the plant is using the cleanest technology in the world and has hundreds of sensors to monitor the air quality every single day. The engineers have even promised to make the plant net zero by the year 2050, which means they will find ways to capture all of their carbon emissions so they don't hurt the planet. This balance between building a massive industry and protecting ancient history is one of the hardest parts of the entire project. Building a project this big takes a lot of money and a lot of people. The total cost is $6.4 billion. To help pay for it, the government provided loans worth $475 million to build the port, the water pipes, and the plant itself. During the construction phase, there are about 2,000 people working on the site. To house all these people, the company is building more than 100 new homes in the town of Karatha as part of a project called Project Vesta. As of early 2026, the project is 66% complete. The engineering is 99% finished, and most of the materials have already been bought. The construction team is working day and night to meet the due date of early 2027, which is when the first urea pellets are expected to roll off the conveyor belt. Once it is finished, the plant will provide 200 permanent jobs and will help Australia grow its own food for the next 40 years. It is a massive bet on the future of farming and engineering. If you enjoyed learning about the massive engineering behind the Perdaman urea plant, make sure to hit the like button and subscribe to the channel for more videos on the world's largest industrial builds. Let us know in the comments what you think about building such a big chemical factory near ancient indigenous rock art. And don't forget to turn on notifications so you never miss a new story. Thanks for watching, and see you in the next one.